Hello, welcome back. Today I'll be doing this problem. It's problem A7 from the Putnam mathematics competition, and the year is 1945. It says, prove that for m and n integers, the equation m squared plus 3mn minus 2n squared equals to 122 has no integer solutions. Now, the best way to approach this problem is to first know the method of proof we need to use here. And for this problem, because we need to prove whether the existence of these two integers, the best way of proving this is to use proof by contradiction. By contradiction. Now, since we are asked to prove that this equation has no integer solutions, why don't you assume the contrary, or assume that this equation indeed has solutions? So let us assume that the given equation has solutions, has integer solutions. M and n. Now, if we assume that this equation has integer solutions m and n, then this is true, and m squared plus 3mn minus 2n squared equals 122, then they should satisfy this equation from our assumption. Now, I'm going to do some algebraic manipulation. I'm going to factorize or complete the squares. And to do this, I'll first multiply this equation by 4. So I'll get 4m squared plus 12mn minus 8n squared equals to 488. Now, what I'm going to do now is to observe that this is 2m whole squared plus 2 times 2m times 3n. So here I can take plus 3n squared whole squared minus 3n whole squared, then minus this 8n squared equals to 488. Now here I'll get, this is a perfect square, so it's 2m plus 3n whole squared minus, this is 9n squared minus 8n squared is just minus 17n squared equals to 488. Now, here, from here, we see that we have this expression is a perfect square, and minus 17 times a perfect square. Now, since this is, we are working in the set of integers, m and n are integers, why don't we take mod some number? For example, this number should be chosen accordingly so that we can get a beautiful result and make our conclusion. Now you see that if I take mod 17, because here I have 17 times n squared. If I take mod 17, then this term will vanish. So we'll just remain to check possible values of 2m plus 3m whole squared. So let's take mod 17. Let's take mod 17. Let's take mod 17. If we take mod 17, we get 2m plus 3m and whole squared minus 0 is just congruent to this number. 488 is 12 mod 17. You can just do it, just take this number and divide it by 17 and then see the remainder. If you take 488 divide by 17, you just get a remainder of 12. So the next thing I'm going to do is see, is this possible? Can 2m plus 3n whole squared be 0, be 12 mod 17? Because we see that this is just an integer. For whatever m and n are, this expression is an integer and it's a perfect square. So let's observe the pattern of perfect squares mod 17. Let's observe it from the next page. Uh, let's observe the pattern of these numbers mod 17. Let's take 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to stop to 8 because if I say 9, for example, then 9 is the same as minus 8 mod 17. So if I just take the square of 9 mod 17, it will be the same as the square of minus 8 mod 17, which will be the same as the square of 8. So in fact, all this now, if I stop to 8, is because for all other remaining numbers, you just like be repeating all these numbers. So if I take 0, 0 square is just 0, which is 0 mod 17. And then 1 square is just 1, which is 1 mod 17. 2 square is 4, which is 4 mod 17. And 3 square is 9, which is 9 mod 17. 4 square is 16, which is negative 1, or I can just leave it 16 mod 17. 5 square is 25. 25 is just 8 mod 17. And then 6 square is 36, which is 2 mod 17. And 7 square is 49, which is just 15 mod 17. And lastly, 8 square is 64, which is 13 mod 17. Now, here you can see that any square or any integer can either be 0, 1, 4, 9, 16, 8, 2, 15, 13 mod 17. But from previously, we saw that this number, 2m squared, is congruent to 12 mod 17, which is clearly a contradiction. This is a contradiction because any square, we know that any integer, any integer, a square is either a zero, any of these numbers, 0, 1, 4, 9, 16, 8, 2, 15, or 13, or 17. For any integer a. But this previous expression, we have seen that 2m plus 3m all square is 12 mod 17, which is clearly a contradiction, which this contradiction arises because we have assumed that the given solution, the given equation has integer solution. So if you assume that the given equation has integer solution, we reach a contradiction. So therefore, the given equation has no solution, has no integer solution, no integer solutions. And this completes the proof of this problem. And this is the end of the video. Thank you very much. Please don't forget to subscribe and to like this video. Feel free to suggest any alternative and comment in the comment section. Thank you very much and see you later for a new video. Thank you and bye bye.